Okay, so we remember what a trapezoid looks like. We have, so we'll go back to geometry. It has two parallel sides, and the other two sides are not parallel. So the two sides that are parallel are your base 1, base 2. It doesn't matter. Now, I put two right angles in there, but you're going to see why. This is going to be represented by the height. Okay, so this formula hopefully looks familiar. Now, there's some variations on it. Some might have done 1/2 times the height, and then base 1 plus base 2 in parentheses, or you could put the whole thing over 2. I like this format because this is what the book will use. Okay, now what's going to be different? So remember yesterday we used rectangles to approximate the area under the curve? Now we're going to use trapezoids, but we're going to flip the trapezoid on its side. So now the height will be on the bottom, and our base 1 and base 2 will be switched around. There's a reason for this. The height is now going to be represented by our subinterval length. Okay, whereas yesterday when we did the base of the rectangle, that was our subinterval length. Now we have to think of it as a trapezoid that's like switched around. So let's say we want to estimate the area under this curve using some trapezoids. So let's say I take this to this point, this to this point, this point to this point, just kind of, so you can kind of see. You get a closer approximation. In fact, trapezoidal approximation is the most common that we'll see on the AP exam. Midpoint is usually like the least popular, we'll say. So if you look, right, you see our little right angles here at the bottom. You see why I switched around the trapezoid? So each of these will be a height, right? And then maybe we have a base 1 and a base 2. Right? And then we have another one, base 2, base 3, base 3, base 4. Okay, so when we're doing the trapezoid method, the height is the length of each subinterval. That's what I was mentioning up top. And the bases are the function's value at each endpoint. Okay, so when we're doing base 1 and base 2, we're plugging into the function. Good. That's fine. That's fine. Okay. Okay, so we're going to approximate the area of the curve. F of x equals 1 over x. So that's part of, remember, that's like a rational function. We want to go from 1 to 5. All right, so from 1, so from here to here. And we want 4 subintervals of equal length. So that means, well, 5 minus 1 over 4, we can easily see each of these subintervals will have a length of 1. So that's my height of each trapezoid. Okay, so I'm going to say T equals
1 parentheses.
Well, okay, so remember what I'll do for this one, I'll do this one as like each individual trapezoid, and then we'll see. So it's h over 2. Here's base 1. Well, what happens when I plug 1 in here? I get 1. Oh, sorry, yeah, I said I was going to do them separate. 1 plus, what would base 2 be?
0.7.
We'll plug 1 in, or plug 2 in. 1 over 2. Okay, the next trapezoid has a height of 1 over 2. Base 1 will be a half, and base 2 will be a third. Okay, 4 subintervals, I'll have 4 trapezoids, just like I had 4 rectangles. Okay, next, now I'm going to do 1/2 is going to be, now you see the pattern, 1/3 plus 1/4, and the last one will be 1/2, 1/4 plus 1/5. Okay, and we will plug that all in. H over. Okay, we get 1.683. Sound right? Good. Okay. Any questions on that one? Yeah. Yeah.
Like, when you ask to approximate the area, will you tell us which method to use?
Oh, yeah, absolutely. Absolutely. Yeah, I should have said using trapezoidal approximation, but. Okay, now let's put that together and make it a rule. And this can, just so you know, this can only be used when the subintervals are of equal length. So like the previous one. Otherwise, we have to do each individual trapezoid. Now, what do we notice about the above problem? So we had h over 2 in each one of them. So look over here. What if we just put h over 2 all the way on the outside? And then we had 1, but then we had a half twice. So y sub 0, so the first one we used 1. But a half was used twice. What else was used twice? A third and a fourth. And then 1/5 is just used one time. So this is kind of a shortcut to figuring out the above. Now, you don't have to do that. If you want to just do each individual trapezoid each time, that's fine. It just makes it a little less computation. And just so you know, the trapezoidal approximation is the average of L and RRAM. So if you already had to find LRAM and RRAM, you could just average the two, and that's going to be your trapezoidal. No, MRAM is different because that's using different values. That's using midpoint.
Would it just be 1 plus 1/5 divided by 2 then?
Wait, which one?
If you'd use that formula, would it be 1 plus 1/5 over? Oh no.
Wait, in this case,
You'd have to still do each individual and then average them.
Like, what's y1 in like that in this one?
Oh, those are the, so if you remember, the bases are determined by the function's value. These are your y values. So that's why I said y sub 0.
I don't know how.
Oh, okay. Think of y sub 0 as like base 1, and then 2 times base 2, and then 2 times base 3, and then 2 times base 4, but then base 5 was only used once.
I get it.
That's basically what we did up in the, that's what we would have done up here. Okay, so let's look at a region R. We have y equals the square root of 2x. So let's see. So we can have 0, 0. What else would be easy to plug in?
No.
How about 2? Plug 2 in and we get 2.
Oh, 2.
Plug in 8, we get 4. Okay, so here, that's the region that we want to approximate the area underneath. So, and it goes from 0 to 8. Now, 0 to 8 with 4 subintervals of equal length. So, that's going to make each height 2. So here, here, and here. So let's practice using the shortcut for this one. Okay, so h over 2. So that's just going to be 2 over 2. Okay, the first one, so plug in 0. So that's just going to be 0. I'm just going to write it out so you can see where I'm getting the numbers from. But then this one will be used twice. So it'll be 2 times square root of 2 times 2 plus, now we're going to plug in 4. So it's going to be 2 square root 2 times 4 plus 2 times square root of 2 times 6 plus just square root of 2 times 8. Just once, right? Because the first and the last are used one time. All the ones in the middle are used twice. Now from here, you can literally just plug this into your calculator. You don't need to simplify radicals. You don't need, but I just need to see this initial setup. Now, if you just left out the first term because it was 0, that's fine. I'm not picky about that. And if you made that a 4 right away, that's fine as well. But from here, what do we get? 20.585. 24? Oh. Okay. Good? Okay, let's try another one, and then we'll do some tables. No questions. We're good? Pretty straightforward. Okay, so let's do the graph. Y equals negative x squared plus 4. So that's going to have a y-intercept at 4 and an x-intercept at 2. So it's going to be this part of the parabola. Because it's
Set that equal to 0.
Yeah, set that equal to 0. You'd get an x-intercept at plus or minus 2, but we just want that part of the curve. Okay, so it goes from 0 to 2, and it's got 4 subintervals. So what's our height going to be this time? 0.5. Okay, so we'll have one here. We'll have one here. Right, so this will be a half. This will be 3 halves. Right, and you can kind of picture the trapezoids connecting those dots. So you see why trapezoidal is more popular? It's like a much better approximation. Okay, so now we have t equals, so it's going to be a half over 2. Okay, so this one gets to be used one time. So that's just going to be 4, right? Plus 2 times, now plug in a half. So that'll be what? Negative 1/4 plus 4 plus plugging in the 1. We're going to do that twice.
So it'll just be 5. Wait,
Oh, don't forget, because that negative's outside the, so it would be 3.
Oh,
Just 3, because it would be 1 squared and then negative. Okay. Look back at the formula. Yeah, it's the shortcut. So then we do 2 times. Okay, now we plug in 3 halves. So that'll be negative 9/4 plus 4. And then the last one time, right? So plug in 2, we get 0. Add that all up.
Is it like not right if we write 1 instead of 1/2 over 2?
Well, wait, that'll be a 4.
What? 1/2 over 2?
1/2 over 2 is
1/2 times 2 over 1.